Hi guys, and welcome to today's flipped instructional recording. We are talking about Unit 2 and getting into the first lesson on matter. So please be sure that as you watch the recording or read through the lessons that you are taking notes using your science notebook slides or either on paper. You want to make sure that each note page is labeled with the lesson number and your notes, and don't forget the guiding questions as well. So you want to update your slide. If you're using that PowerPoint slide template, make sure you update the lesson number and name as well. So as we get into the new unit, we get a unit introduction. We're covering matter. So the essential question, things that we're looking at, is how do atomic and molecular interactions explain the properties of matter that we see and feel? So this gives you some essential questions to write in your science notebook. We know that matter is the substance all around you. We defined that in Unit 1. We know that it's anything that is made of tiny particles called atoms. And so we got examples of that. It's asking you on the left side of your notebook, so the first thing you're going to take some notes on is to draw some diagrams and make some notes about matter. Remember that we'll also be looking at those guided questions coming up as well. So does matter matter? This may seem like a puzzle, but it isn't. Matter is a very versatile word. So in English language, it has many meanings in life. In science, matter has another meaning altogether. So what is matter? So we know, we can see down here that it kind of gets in the way with this page bar here, but let's see if I can get it to slide up or down. Nope, it's just right in the way. Everything is made of matter. So if we're looking at this picture, everything in the picture, the air, the rocks, the waterfalls, everything. All right, so here is a periodic table document. There is one I actually even like better. If you go to the website P, like the letter P, Paul, table, ptable.com, and print out that one. It's color coded and very user friendly, so I encourage you to have that printed out so you can utilize it as you go through the unit. Here is that science notebook template. So remember, you only need to open one of these. This will be your Unit 2 science notebook, so you don't want to add on to Unit 1. And then you'll be starting out 2.01. This is your first lesson. Here are already some things that you could put on the note side. You've got covalent bond, ionic bond, and valence electrons. If you prefer to hand write, that's okay too. Remember, label, this would be 2.01 notes, and then put all of your notes down, and then make sure you go to 2.01 guiding questions so that I can clearly see both of those. So here are the guiding questions, and I'm going to screenshot those so we can look through and make sure we get answers to all of those as we go through and read the lesson. So I'm just going to put this on another screen. Sorry, my computer's being funny. Actually, I don't need any of these. I don't know why it opened all of them up. We just need a new Word document. There we go. So I'm just going to put this over to the side. You can also copy and paste the questions in and just type in some space in between so that you can answer them. So just make sure you have these and that they're clearly labeled. All right, so we've got the scientific definition of matter. We found that basically anything that has mass and takes up space, or it has mass and volume. That's guiding question number 1. There are many ways that matter can be described. So how would you describe these things? A gold bar. So if we're looking at these bars here, you could say it's gold, it's shiny, hard, metallic, it's a solid, something like that. What about a helium-filled balloon? Think about that. You could describe it like latex or rubber, the sphere, so its shape that has less dense than air, meaning it floats. It doesn't, it would be more dense than air if it fell to the ground. And then an ice cube, we know that it would be square, solid, cold, wet, things like that. So matter can be described using these 6 properties, and this is the answer to guiding question number 2. Density, melting point, boiling point, chemical composition, chemical reactivity, state at room temperature. That means, is it a solid, a liquid, or a gas at room temperature? Room temperature means roughly 70 degrees Fahrenheit. Molecules in motion. So this is going to answer question number 3 of the guiding question. Do you know that your desk is moving right now? Even though it seems to be perfectly still, the molecules that make up your desk are moving. Molecules are constantly in motion. The motion of molecules changes as matter changes from one state to another. So believe it or not, the solid phase molecules are still moving while they're located in fixed positions. So this may be something you want to put over on your notes side, and I think that a drawing is really helpful here. So you could draw something like a beaker with some molecules in it, or something that's tightly packed, molecules tightly packed together. That would be a solid, and we know that they're still moving, but they're in a fixed position and they just kind of vibrate back and forth. So when a solid melts into a liquid, so think of your ice cube melting into water, the molecules gain energy and they move faster. Okay, so I would draw a picture of like an ice cube and put tightly packed molecules, low energy. And then I would maybe draw an arrow, water melting, liquid. And I would put the molecules gain energy, they move faster. And then maybe draw another arrow. As the liquid gain more energy, they move faster, converting the substance from a liquid to a gas. So think about water evaporating into the air. The gas molecules are able to spread out. They're no longer tightly packed together, so they are moving very fast. So a gas, lots of energy, moving very fast. So which type of phases possess the least amount of energy? That would be a solid. They're tightly packed together. To convert a substance from a gaseous to a liquid phase, what has to happen? So think about gas, right? We have evaporated water like a cloud. And for that to go into a liquid, think about rain. What has to happen to that energy? Energy has to be released or lost. So it's going to go to a lower energy phase. So you may want to even write that out. Okay, so that answers question number 3. And now this will answer question number 4. We're talking about chemical versus physical changes. So sometimes when a substance changes, you can still recognize it. So this is because it's able to maintain its original identity even after the change. So look at the picture here. It says take a piece of paper and tear it into pieces. You can still see that you have paper. This is a physical change. The identity of the paper has not changed, but if you set a piece of paper on fire, you would be left with a pile of ashes, and you wouldn't be able to recognize the paper anymore. This is a chemical change. So look at the difference between physical and chemical changes. You might want to put some of these in your notes. So you've got the paper example, burning paper, right? This is a chemical change. So in a chemical change, the chemical composition of the substance must change. Chemical bonds are broken, new bonds are formed, so you're getting a completely new substance. That's something you want in your notes. Chemical change. The identity of the substance changes. Okay, so determine if the type of change, what's going on here. Determine what type of change it is. Baking a cake. That's chemical because the batter has now formed something new. Melting an ice cube, physical. It's still H2O, it's still water. Cutting bread, it's physical. Still the same pieces, we can identify the bread. Boiling an egg. Boiling an egg changes the protein. So when we're doing something like that, we know that's a chemical change. So we've answered the difference between physical and chemical changes. Now we're moving on to question 5. What is an atom? Who is Adam? Atom is not a person, but rather a thing, an extremely tiny thing. Atoms are particles that are the building blocks for all matter. So that answers question number 5 for you. The properties of atoms determine the properties of elements, ions, and molecules. So in this unit, we're going to learn more about atom, its composition, and how atoms make up everything around you. So here is some vocabulary matching. This is a great activity for you to go through and just test your vocabulary skills and see how well you're doing with these terms so far. Here is a periodic table. It includes lots of information. This is going to be question number 6. It's telling you about atoms of each element. So at first glance, the table seems oddly shaped. And it's almost in a different language with its numbers and letter symbols. Even the location of each element on the table is important. So horizontal rows on the periodic table are called periods. That's something I would put in your notes. Horizontal rows, meaning they go left to right, like the horizon. Maybe draw yourself a picture, an arrow. Horizontal rows are called periods. Vertical columns. So think about a column like on your front porch that holds up, the roof or a wall in your house. Those are called groups or families. Same thing, groups or families. So elements in the same group, okay, going up and down, they have very similar properties. So think about your family, right? Group and family, same thing. You guys are not identical, but you have a lot of things in common. Maybe hair color, skin color, height, your body shape, things like that. So you are similar. You're not identical, but you're similar. So that is the same way with the elements in the same group or family. So there are, if you look, it says find elements, find group 17. They are all non-metals and they're very reactive. So this, you'd have to kind of blow up bigger. It's very hard to see on this page, but it's, everything is in a group or family. So going up here, you have 1 through 18. There's 18 groups or families, and they are non-metal. So 17 is here. So they all have, they're highly reactive. They all have those things in common. These are called the halogens. All right, so let's see, the periodic table, what is it used for? Remember, if we're answering that question, it's used to identify elements. It's used to identify each square has important information. We've got the symbol on each square, so that's the letter. Notice that 1 or 2 letter symbols refer to the name of the element. This is aluminum. So you're always going to have, if it's got 2 letters, uppercase and a lowercase. You always want to make the second letter lowercase. So this is not AI, it's AL, and that's aluminum. So let's see, sometimes the symbols are not similar. For example, PB, that element is lead. So it's from the Latin word plumbum, and that means liquid silver. So what does the element symbol represent? That is the abbreviation representing the specific element. What element do you think the symbol C represents? So C is element number 6. Elements go in order. This is 1, 2, 3, 4, 5, 6. So they go in order from left to right. Okay, and that is carbon. And what element do you think the symbol S represents? So S is over here, and you might be thinking silver, but it's actually sulfur. Okay, and we just talked about silver. It's actually PB. All right, so going on, numbers on the periodic table. So there's a lot of numbers going on here. You've got 1 at the top, 1 at the bottom. The atomic number is also found in the square directly above the chemical symbol. The atomic number is a whole number, and it represents the number of protons or positive charges in the atom. This number is different for each element, so no two elements can have the same atomic number. The other number you see that's listed under the symbol, so down here, it's a decimal usually, is the atomic mass. So you can round that number usually. Those kind of go in order as well. You'll notice that they're in order of their atomic number and their atomic mass. So hydrogen, which is up here, element number 1, has a very small mass. But aluminum over here, it's element 13, you'll notice that has a heavier mass. So the other number you see, we know the average atomic mass. This number is not a whole number. It represents the average of the masses of the atoms for that element. So what does the atomic number represent? That is going to be the number of protons in an element. And you'll also find that that's also equal to the number of electrons. So I always tell my students, if they can write this in their notes, A equals P equals E, that means that the atomic number is equal to the number of protons, which is also equal to the number of electrons. The atomic mass, okay, it's also called the mass number. It represents the average of the masses. So what's the element symbol and atomic number for the element phosphorus? So if you look at your periodic table, this would be where you would want to have the one printed out that I mentioned. That is P. The atomic number is 15. So it's element number 15. And what is the elemental symbol for and the atomic mass for the element calcium? So calcium is Ca. It's over here. It is the atomic number, mass, is 40.08. Scientific discoveries. So we've gotten a lot of things answered here. We were able to answer 6. We were able to answer 7. And now we're answering number 8. Some important discoveries about atoms. So scientists have made new discoveries. Their understanding of the composition of the atom has changed. Some discoveries were made because of new technologies, while others were purely by accident. Each discovery has given a more accurate picture of the atom. When J.J. Thomson discovered the electron, he proposed a model of the atom, which is a largely positively charged sphere, and it was balanced out by a number of electrons embedded throughout. A student of Thomas's, Ernest Rutherford, later disproved this, giving rise to the existence of the nucleus. So we didn't have that idea before. This is something too I think is helpful to put in your notes. You might start with J.J. Thomson and draw out. He basically had a large circle with electrons like stuck in it. So think like about a ball of cookie dough with chocolate chips stuck in it. That's what his model looked like. So you could draw that in. And then an arrow showing Ernest Rutherford, he figured out that there's a nucleus in there. So that changed the way the model looked. So then you could go over and draw a circle with a circle inside, and we know that circle would be the nucleus. From there, you could draw another arrow showing Niels Bohr. He further changed the way the atoms are viewed. He hypothesized that electrons followed a predictable pattern, a path that's similar to the orbit of the planets in the solar system. So he based these orbits on energy levels in various line spectra experiments. And this model is so effective that it's still introduced as a starting point for understanding the atom to this day. So a true model of the atom was developed by scientists in the early 1920s and 30s with the development of quantum mechanics. So this is what we're looking at with Bohr's model, right? So we've got the electrons orbiting. You can see that's what those circles are. And we can see a nucleus. We know that protons and neutrons live there. So I would make sure you have the name and the picture of what their discovery looked like. That would be a great thing to have in your notes. All right, so that answers number 8. And why are materials constantly changing is number 9. Change, change, change. Everything changes. The materials around you are constantly changing because the materials on Earth consistently undergo chemical changes. There's your answer. During autumn, tree leaves change color and eventually fall to the ground dead. Animals consume food created by plants, which is then digested and broken down. Seeds use nutrients from the ground to grow and produce new fruit. In every aspect of the world, matter is always changing. All right, so we've gone through the entire lesson. You can take a look at the lesson review here. It goes over what is matter. Physical and chemical change is different. So that can even answer some of the questions that you may have missed. And then how are the phases of solid and liquid gas different in terms of energy? So you can do that. And then you are finished with 2.01. So we've answered all the question and given you some really great notes. So from there, be sure to look for the flip follow-up session in your Class Connect schedule. And you can attend Help Lab if you have questions specific to this lesson or any lesson. So have a great day, everyone, and thanks for watching.